Today we'll dive into the basics of one of the most powerful and commonly used Linux features, that is input-output redirection. Let's begin with an example. Imagine you've been tasked with providing a list of all the files in a specific folder and sending them via email. At first glance, it seems simple. Just use the ls command followed by the folder name and then copy and paste the output to an email. But there's the catch. There are hundreds upon hundreds of files in that folder, and manually copying them all would take hours. This is where the output redirection operators comes to rescue. These operators allows you to redirect the output of your Linux command to a file. So let's run the ls command again, but this time we'll add the greater sign followed by the desired file name. You'll notice that the ls command doesn't display any output on the screen this time. Instead, the output has been redirected to a file. To see the contents of the file, we can use cat command. Everything we listed earlier is now inside that file. However, it's essential to keep in mind that every time you use the redirection operator, the target file will be overwritten. Let me demonstrate. I will list the content of the current directory and send the output to the same file. If we examine the result file, you'll notice that it no longer contains the previous data. It's been replaced with something else. Here's one more handy trick. Sometimes you just need to clear a file. It's as simple as using the redirection operator without any input, effectively directing nothing into that file. Voila! The file is now empty. This can be quite useful, especially if you need to trim down a log file that has grown excessively large. So, now you know how to redirect the output from a command to a file. What if we want the data to be appended instead? Let's imagine you have a scheduled job that regularly produces some output. To simulate this, I will run simple example using echo and date. At this point, the specific task of the script isn't crucial. What matters is the output it generates. You may want to maintain a historical record of all the script's output in a file. In Linux, we refer to a text file that records events, messages, or information about running application or service as a log file. Now, here's where the append operator comes into play. This operator appends the output to a file without overwriting any existing content. Let's give it a try. You'll find yourself using this operator quite frequently when creating log files for your scripts. In Linux, we have a stream called stdout. This is where a program or process typically writes its regular output. By default, it's connected to the terminal, so when you execute a command, its output appears on the screen. However, with the help of redirection operators, you can direct this output to files. There's another stream called stderr, where a program or process typically writes error messages and diagnostic information. Like the standard output, the stderr is also connected to the terminal by default. But it's important to note that it's a separate stream. Let's generate some error messages as an example. I will attempt to list a directory that doesn't exist. This will help illustrate the distinction between standard output and standard error. Alright, we encountered an error message stating that the directory does not exist. But what if we'd like to redirect this error output to a log file? Let's give it a shot using the output redirection operator. Now, what just happened? The error message still appeared on the screen and our log file remained empty. Here's the explanation. The output redirection operator only redirects standard output, not the standard error. To redirect standard error to a file, we need to use a different operator. Let's try that. We've successfully redirected the error message to our log file instead of the screen. Because the standard output and standard error streams are separate, we can redirect them independently to two distinct files. Let me demonstrate this by listing the contents of an existing directory and attempting to list a non-existing directory in a single command. We received both an error for the non-existing directory and a valid result for existing one. This is because both standard error and standard output are linked to the terminal. But we can change that. I will redirect standard output to output log and standard error to error log. To achieve this, we use the command followed by the standard output redirection operator and the log file name. Then we use the standard error redirection operator and the error file name. This way, our regular application output is logged separately from any error or diagnostic messages. There are a couple of additional points to note. Sometimes you may want everything in a single log, including both standard output and standard errors. One way to do this is to enter the command redirect standard output using the append operator and redirect standard error similarly, pointing both to the same log file. However, there's a simpler notation that you'll often find in other people's script. Essentially, you run the command redirect standard output to a file, and lastly, redirect the standard error stream to the standard output stream. Now, let's take a moment to dive a bit deeper into how Linux manages open file, sockets, and other input-output resources with file descriptors. A file descriptor is essentially a non-negative integer that serves as a unique identifier for a file input-output channel that a process has opened. Every process is allocated 3 standard file descriptors, also known as standard streams. Standard input number 0, standard output number 1, and standard error number 2. Now, if we analyze our command once more, it starts to make more sense. To represent the file descriptor of standard error, and 1 represents the file descriptor of standard output. We are redirecting standard error to standard output, and then we are redirecting standard output to a file. Because this kind of redirection where both application output and errors are captured is quite common, there's a dedicated operator, ampersand greater sign, that simplifies the process. Let me show you. As you can see, both standard output and errors are redirected to a single log file. The second point to mention is a common scenario where you want to discard the output entirely or just suppress the error messages. In Linux, there's a special device called devnull. Anything redirected to that device will be discarded. Let's begin by discussing how to discard error messages. I will demonstrate this using the find command. As a regular user, I won't have access to all the folders, which will cause find to display errors. Sorting through all of those error messages to find the actual result can be challenging. To simplify things, let's discard the errors by redirecting the error stream to devnull. I'm running the same command again, but this time I'm adding error redirection and pointing it to devnull, which effectively discards any error messages. Yup, all errors are gone. Let's dive into one of the most powerful features of Linux: pipes. A pipe is a mechanism that enables you to connect the standard output of one command or process to standard input of another, creating a seamless data flow between them. The symbol used to create a pipe is the vertical bar. Let me provide you with a basic understanding of what it can do. One of its most common use cases is text filtering. There's a command called Grep that searches a file for a specific pattern. To demonstrate, I will list a file containing English words. Let's say we want to display only words containing ZO. To achieve this, we'll pipe the output of the cat command to the input of grep command. Great, the grep command has successfully filtered the output, leaving only the lines that contain ZO. Let me introduce you to the few basic grep options. If you want to search for lines that begin with ZO, you can add the caret at the beginning of the pattern. If you are looking for lines that end with ZO, simply add the $sign at the end of the pattern. To search for empty lines, use both the caret and the $sign. If you don't care about the case and want to perform a case-insensitive search, you can use the -i option. Another handy grep option is -v, which performs an inverted match. For instance, if you want to find words with ZO, but then filter out all the words that start with ZO, leaving only words that have ZO in the middle or at the end, you can add another pipe to pass the results of the first grep to second grep and then perform an inverted match. You can see how powerful this technique can be, chaining multiple commands together. To sum up, with grep you can also display line numbers with -n option. Include lines before and after the match with the -a and -b options, and use very powerful regular expressions, which we'll cover in a separate video. Grep is a tremendously valuable tool that you'll use frequently to find specific data in your application logs or to filter the output of your commands. Another useful command that you'll often use with pipes is wc, which stands for word count. It counts lines, words, and bytes. Let's say we want to count the number of lines in our words file. Let's simply pipe the words file to the wc command and use the -l option, which stands for lines. This dictionary file contains over 100,000 lines. The wc-l option is frequently used for counting lines. If we want to count lines that contain the letter A, we can first pipe the file to grep to filter out the lines and then pipe them to wc to count those lines. It's worth noting that grep has its own -c option that can count those results as well. So we could write our command like this. Another common use case for piping is sorting data. To achieve this, we just need to pass the output to sort command. The text is now sorted. You can also sort in random, numeric, or reverse order. You'll find it very useful to pass the output of sort to unique. Unique remove duplicate lines. Let me demonstrate. I will display only the first 3 characters of every line using the cut command, which can cut and remove sections of each line. As you can see, there are multiple duplicate lines. To get rid of those duplicates, we'll sort the output and pass it to the unique command. Let's count the numbers of results using wc. We've reduced the line count from 100,000 to 5,000 by removing duplicates. Additionally, it's possible to display only the duplicated lines, count the duplicates, or display the number of occurrences of each line sorted by the most frequent. Sometimes you may need to display only the beginning or end of a file. There are 2 commands that can help with that. For example, if I want to show only the first 5 lines of our file, I will pipe the output to head command with the -5 parameter to indicate that I only need the first 5 lines. On the other hand, the tail command shows only the last part of the file. Let me list the last 5 lines of our file by piping the output to tail-5. With tail command, there's a useful switch called -f that displays the last 10 lines of the file and blocks, waiting for new input. This is very useful for live troubleshooting. You can attach to a log file and wait for new messages to arrive. There's one more command I'd like you to be aware of. Less. Let me show you what it does. Less opens the stream in read-only mode, displaying the first page. You can navigate up and down with arrow keys, go page down or page up, jump to the end with the capital G, jump to the beginning with lowercase g, and search for specific text with a /. You can jump to the next result with lowercase n and jump to the previous result with an uppercase N. A useful feature is to jump to the end with capital G and press the question mark to search backwards. Log files often have the most recent entries at the end. With this approach, you can search for the most recent occurrence of error. Lastly, you can filter less output with an ampersand. Let me show you. The output is showing only lines containing specific text strings.